So what we want to do is I like to draw the picture. Actually, it's really the only way to do it because it frees my brain up from if I can make one calculation, one decision at a time, that's helpful. So for this problem, it says that if sine of theta is equal to -1/7 and its terminal side is in quadrant 4, find cosine of f of theta. So, or cosine is a function of theta. So what we need to do is just draw our xy plane. Okay. And then we know that it's going to remember also this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So it lives over here somewhere. So also remember that sine of theta is equal to y over the radius r. So that means that my radius is 7. And also my y value is 1. Where the negative comes in, I don't know what x is, but I know that to live here, my y value has to be -1. Because the radius is always going to be positive, right? It's only the x and y values that are negative. And we should also point out that our x value, whatever it is positive. Because in order for it to be in the fourth quadrant, your x value is positive and your y value is negative. Does that make sense? So from here, it's pretty much what we've been doing. I just need to find the rest of the sides. In other words, this is -1. I don't know what x is, right? But I do need to figure out what x is because cosine of theta, cosine as a function of theta, is x over r. So I got to find out what x is. So then we just go back to what we know. We know that x squared plus y squared is equal to r squared. So then what's y? Well, y is -1, right? Squared. R is 7 squared, and then we have x squared. Well, when we do the math on this, -1 squared is -1 times -1, so that's just 1. And then 7 squared is 49. I'm going to subtract 1 from both sides, right? Regular algebra. And I get x squared equals 48. I'm going to have to take the square root of both sides. Sorry about the sloppy handwriting. And I get x is equal to the square root of 48. Now, this is where we don't feel the most comfortable, is simplifying radicals. So before I plug this in, let's simplify this radical. The square root of 48 might be divisible by one of the perfect squares. So in your head, you need to think of and write this down in your notes. What's 2 squared? 4. What's 3 squared? 9. What's 4 squared? 16. And so if you keep going, oops, ran out of space there. If you keep going, you can go on forever. 8 squared, 9 squared, 10 squared. That's what you want to look for. Well, then I think to myself, is 48 divisible by any one of these numbers? 16, right? because 16 times 3, actually, and we'll write it down over here so it's not in the way. 16 times 3 equals 48. But if you don't know that off the top of your head, one thing that you could do is, and I'll show you this trick, I learned this trick and it works great. You could just use a calculator and just divide by the perfect squares and find out what divides evenly into it. So if I let me make this a little bigger so you guys can see it better. So what I would do is I would say 48 divisible by 4. Yeah, that works. 48 divisible by 9. And you want to get a pretty big number and see. Then 48 divisible by, the next one is 16. That works. And you could keep going. There isn't a number that's bigger than that. But the next perfect square would be 25, right? And you could see if 48 is divisible by 36, which we know isn't true. But I want to show you this algorithm that we would do. We just keep dividing our number by the perfect squares. 4, 9, 16, 25, 36. Okay, 16 is the biggest one. So in other words, 16 times 3 equals 48. Now, the reason we want to find that out is because the square root of 48 is the same as the square root of 16 times the square root of 3. But I know what the square root of 16 is. It's 4. So this is the simplified version of this. All right? And this is what we said was our x value. So over here, we would say cosine of theta is equal to x over r, but now we know that x is 4 square root of 3 all over the radius, which is 7. Now the only thing that we want to do is we want to double check at the end and make sure that x is actually a positive value. In other words, what I want to make sure is, will this work? Can x be a positive 4 root 3? And the answer is yes. You always want to double check that because sometimes you'll need to switch it to negative. In other words, if it lived over here in quadrant 3, I'd have to change that to negative 4 root 3. So we got to think about that. The calculator doesn't